what is operating system? So it's basically a software which acts as a manager of hardware. So our computer system, our mobile device, our computer system is basically a bunch of things together. So it comes with hardware as well as software, and operating system acts as an interface between computer and the computer hardware as well as and the user. So to just hover over what exactly operating system do. So it basically performs all memory management operations, processor management operations, device management operations, file management, security control, job accounting. So all these words might seem overwhelming, but yes, so we will be talking one by one on each of these, and we try to be every layer where and how operating system is working. So the agenda for today's discussion is to discuss some of the intrinsic details of what exactly, giving you an overview of what exactly operating system is doing. So coming back to my previous definition, operating system is an interface between computer hardware as well as and user. So its goal is to provide an interface where user can start their applications, and it provides a seamless environment for running those applications efficiently. So I mean that make the computer system convenient to be used. Like if I click one application, it has to respond me within some microsecond or second. Otherwise, if it is taking a longer than 1 hour or so, I will not be using that particular computer system and also discard that operating system. So it's all about making or using computer hardware more effectively. So computer system is divided into four components: hardware, operating system, application program, and users. So we are the users who uses, and at the second level comes the application program, which are something like word processor, browsers, databases, video games, compilers, programs. All these are application programs which are running over the operating system. Now, under and along with the operating system, there is another thing is called system applications. So system applications are used to assist the main component of operating system, that is kernel, which we will be discussing sooner. So here is an diagrammatical view of what exactly I was saying. So there are users who are trying to uh, run their applications on the computer hardware using different system and application programs. So this is how they are interacting with them. So directly, user is not controlling any hardware. User is just sending commands to application programs. Then application programs basically give command to give command to so this basically happens like. So user give a command to database or compiler, and compiler uses give an instruction to operating system, and operating system then runs a command or instruction set onto the computer hardware. So computer hardware you can assume as a microprocessor where everything would be running as an instruction. So we will be going more into detail of how these instructions would be run, but without going into detail of the hardware. So our agenda of operating system is not to teach a hardware, but we will be working closely and we will get to know about how this hardware is also working. So operating system is basically a user wants a convenience, ease of use, and good performance. So this is all which an operating system gives to the user. So, but the shared computer such as mainframe or mini computer keeps all users happy. Users of dedicated systems such as workstation have dedicated resources, but frequently use shared resources from servers. So these are some examples of higher-end systems where users are using those systems for different type of requirement. Uh, so we will be discussing more on it, how this all is happening. So coming back, an operating system is a resource allocator where it manages all the resources, and it is also a control program that controls the execution of the programs to prevent errors and improper use of the computer. So basically, one is its requirement is to manage the hardware by allocating the resources properly to each and every program, and other is stopping and securing the system so that a user program should not intrude into the operating system program, and it should not make use of that operating system in an improper way. So there are mechanisms for that. So for operating system, there's no universally accepted definition. Everything is like everything that a vendor ships, we can consider that as an operating system. But within all these examples, so we should know that there is one program that runs all the time when your computer is on is called kernel. So kernel is heart of operating system, which has the functionality, functions, and so many code things are running, which makes your to perform basic computer operations or from managing the show of running a computer system that we have already discussed at the start of the slide. Now, starting with the next, moving next, so we will try to figure out how we move from the start of the computer to the end. All those programmings are coming. Uh, so whenever a computer starts up, the first program that runs is called a bootstrap program. So it's normally a tiny program which knows when a computer turns on, which knows where is the first instruction to start the kernel. So it knows how to initialize the system, and it loads operating system kernel and starts its execution. And kernel then starts and putting everything into place, and all the processes are into running conditions so that it is available for accepting the user input. So it's just like when you are going to start your program or computer or your system. So it's basically boots up and then asks for the user, gets ready for asking for the user input. So if any one of you has an experience of installing dual booting like Windows along with Linux, then you must have encountered with a bootloader program that is used to load before actually kernel starts working. So it gives an option to which operating system you have to select. So it places those bootloaders commands just before the kernel, which is basically the operating system by default that comes with. So we will be discussing more on it. No worries. So computer system operations and organization it could be one or more CPU devices connected together through a common bus. So here we have a graphic adapter that is used to connect to monitor, printer, keyboard, mouse. So all these are devices, and all these devices are connected to CPU, but that goes through disk controller, USB controller, and graphic controller. So each controller could be another microcontroller or microprocessor. So it could be one or more CPUs, device controller that connect through a common bus, providing access to the shared memory. So basically, this is the heart of interconnection between all uh, these devices, which can access the common memory and the shared memory to run and execute the programs effectively and efficiently. So going forward, I/O devices and CPUs can work concurrently. So most important part of an operating system is to listen to I/O requests and process those I/O requests, and accordingly take the data and deliver to the memory or to the CPU. So these programs can actually run concurrently with the advancement of technology such as DMA, so direct memory access, that is also allowed. Each device controller is in charge of particular device. If you can see back, the USB controller is in charge of not only one but one, two, three particular devices. So this is the, the the power of USB controller, that it can control multiple devices at the same time. So this is basically the job of a device controller. So device controller has a local buffer So from where the data from CPU moves the data to and fro from main memory to the local buffer, and IO device from the device to the local buffer of the controller. So basically, each controller has a local buffer where it puts the information, whatever is coming and whatever is going into the CPU. So whenever a new data comes in, the controller tells the CPU that it has finished the operation by causing an interrupt. So this interrupt is in heart of computer organization or operating system. So this actually tells that there is some operation has been performed successfully or not performed successfully. So based on that, it asks the CPU to take correct action. Now we are going to discuss about the most important feature of operating system, are interrupts. So an operating system is called an interrupt driven software, basically, because it uses interrupts to manage and handle the devices, the processes in the operating system. So an interrupt is basically a service routine. So whenever an interrupt is encountered by CPU, it actually transfer the control of CPU to an interrupt service routine. The type and the start of that service routine is handled in interrupt vector, which handles the type of, based on the type of the interrupt, it stores the addresses of interrupt service routines. So there are two types of interrupts. So basically, one is hardware enabled or generated interrupt, another is a software generated interrupt. Those are called traps and exceptions. Now, other two types can be said, like the interrupts could be maskable, or the other version of it is interrupts can be non-maskable. So maskable is one which can be turned down by CPU if it is already doing some critical work, whereas non-maskable cannot be turned down by CPU, and those are reserved for unrecoverable memory errors. So whenever an interrupt is encountered, the operating system preserves the state of current CPU or user process by storing the register and program counter. This is kind of context switching, and which we will discuss later on. And then we have there are separate segment of code uh, determines what action should be taken for each type of interrupt. So that is basically based on the mapping, and each service routine, interrupt service routine, would have certain steps to determine what action should be performed. Now here is a timing diagram of how the interrupts would happen. This is more like when a CPU is running some user process, and user process requests an IO device to fulfill the IO request. So initially the IO device is idle and the user process signals for the IO request. So whenever an IO request is received by IO device, it started performing the operation, and when the transfer is done, it creates, it signals the interrupt to the CPU. So whenever there is, whenever the transfer is done, the interrupt is signaled, the CPU changes its control, give its control to the interrupt and perform the required operation, and goes back. Once the interrupt is handled, it goes back to the user process. So here is number one request, and then there is another request for IO request by the user program. So now we are going to discuss about storage structure. So there are different types of memories. Those are attached to computer system. A CPU would load instructions only from the memories, and usually that memory is called the main memory, from where the CPU fetches the instruction, then put it into the cache memory, and then to the register for the final execution. Now, the first three memories are volatile memories, which loses the content as the power is turned off, and the and non-volatile volatile memories. Now, as we move up from bottom, so we can see that the speed of these memories are increasing. So this one is slowest, and this is the fastest memory. It means that the access time is actually decreasing as we move. Another difference is as we move up from bottom is that the size all decreases. So this is largest, and as we grow, this would be the smallest in size. So the formation of these memories is also different. So the first top three are mostly semiconductor based memories. Another concept is direct memory access. This helps to independently transfer the data from I/O devices directly to the memory with the minimum intervention of a CPU. Device controller transfer blocks of data from buffer storage directly to main memory without CPU intervention, and it is used for high-speed I/O devices. Those are able to transfer information at a close to the memory speed. So normally, rather than sending interrupt per byte, here the DMA is actually sending one interrupt per block. So here is a block diagram of how this DMA works. So we can see that the thread is running and it initiates the IO request. The IO request would be initiated on the device, but with the initial data transfer and interrupt. So it basically CPU would allow it to transfer data directly to the memory after initial setup with the CPU. So this would actually enable the devices to directly communicate with the memory with minimum intervention of CPU, and the CPU can use those cycles to do other instruction execution and data movement. So DM is a very powerful feature on modern computer uh, operating system. Moving forward, we are going to discuss about single processor system and that form the basis of today's era computer system architecture. In single processor system, we have a central processing unit that comes with a single control unit, single arithmetic unit, and set of registers. Those are used for computing and executing the instructions. In addition to it, it has a memory unit. So that memory unit is used to store the instructions which central processing unit fetches and executes. It comes with input and output devices. So where the input is taken and it is thrown on output devices after processing. So this is a system that is basically a single core, single CPU, single core system. So moving then comes the multiprocessor system. So this is a new era basically. So where we try to connect multiple CPUs together to work on a single application or multiple applications. So those are also known as parallel systems. So it's a new era computing. Those are basically tightly coupled system, and we will be discussing there are different architectures for multiprocessor systems coming to distributed system, cloud computing, and all that new stuff. So what are the advantages of going forward with the multiprocessor systems? So it basically increased the throughput, increase the scale at which you can use your computing resources, increase the reliability, like with the fail-safe. If you have only one processing unit and that fails because it's a electronic circuit, then your whole of the computation and results would go away. So in case of that, we run and we run it on multiprocessor system where the degradation is graceful or fault tolerance is always there. So if some component of a job is down, then there are mechanisms that other system would take that particular load and run it. So that's basically more into distributed system. As we move forward in this particular subject, we will get to know about how these distributed systems would work. Now there are two types of multiprocessing system. One is asymmetric multiprocessing, another is symmetric multiprocessing, in which each processor has equal assigned responsibility and perform all the tasks. That is called symmetric multiprocessing system. And whereas in asymmetric, each processor is assigned a particular task. So based on that particular task mechanism and scheduling, we distinguish between the multiprocessing architecture. So most of the operating system nowadays operating systems are compatible with the symmetric multiprocessing environment. So this is a diagram or the block diagram of symmetric multiprocessing architecture. You can see that you have CPU1, CPU2, and CPU3. They are having their own individual register set and cache, and along with their central processing core. Each has an individual, and they share the data between through a bus. So this is something a shared memory model, but but yes, they have their individual register and cache to run. Now another thing is dual core design. So we these days we see dual core design, quad core design. So in this particular thing, so we have one processor, and within that processor we have cores. So this is core 1 and this is core 2, and this all is happening on processor 0. So processor, it has two cores, and within that each core is responsible and has different registers and cache. Now you can see that there are L1 cache and L2 cache. And nowadays systems are coming with L3 cache also. So basically these all are the levels of the memories which we have discussed previously. So the speed of L1 is certainly better than speed of L2 and then L3 and then the main memory. So the speed is varying, and these all are level of the memory support is provided. So you can see here L2 cache is shared memory, whereas L1 and L1 in both the cores, they are different and registers are different. So this makes a dual core design of a system. Now moving forward, if we say that we can use multiple processors on a single chip, can we use multiple systems on different chips? For example, our computers in the lab, our desktops in our home or laptops, can we use them together to solve one problem? Yes, we can use that, and that is something called a clustered system. Those are working together. So clustered systems are definition which are basically available on LAN, but specifically if I go more to more generic definition, so there are systems which can share they are miles apart, but they can have an access to a shared storage called SAN. So storage area network provides uh, accessibility to each and individual processor whosoever is working on a same particular problem. So it provides high reliability services which survives a failure because multiple systems are working on jobs. So they provides and make our system or network more fault tolerant. Uh, Now there are within cluster system there are two types. One is called asymmetric clustering, where one machine is hot standby, so which actually just look at what is being done, and in case of failure take control of the whole network. And the other is symmetric clustering, where multiple nodes are running and they are monitoring each. We are not going into detail for that, but clusters can use for high performance computing to solve one particular problem, and each shares some component of it. Now, applications are written using specialized programming for parallelism. Now, when they are sharing a single shared resource, how the access is managed. So for that, there is a distributed lock manager who knows which, and if some processor is using that shared block, it actually locks that particular thing. So we will be discussing this into more detail